As with numbers, can we say two sets are equal? Yes, two sets can be equal to each other. Let's find out when they are equal. Two sets A and B are said to be equal if they have exactly the same elements. For example, the sets shown here are equal sets. Consider the sets A and B as shown with elements A, B, C, D, and E and 0, 1, 2, 3, 4 respectively. Are they equal? Clearly, sets A and B are not equal even though each contains 5 elements. That is, the sets have the same cardinality. Sets that have the same cardinality are called equivalent sets, and we can write this symbolically as shown. For two sets to be equal, the same cardinality is therefore a prerequisite condition. In other words, all equal sets are equivalent but not vice versa. Do you think sets A and B given here are equal? Yes, indeed they are, because in sets the order of elements is not important. Let us now check these sets. The set C is the set of letters from the word alloy, and the set D is the set of letters from the word loyal. Are the two sets equal? We can see that both these sets can be written in the roster form as L, O, Y, A, L. So, the two sets are equal. We have seen that sets with the same cardinality are equivalent. But is this true in the case of infinite sets too? In other words, can we say that two infinite sets are equivalent? The answer is no. We can't say this in the case of infinite sets. To understand how two infinite sets may or may not be equivalent, let us listen to a story about two farmers. There are two farmers, each wanting to plant a very long row of seeds side by side in a field. Both the farmers have annoying birds nearby that hinder their efforts in different ways. As the first one walks along the row, sequentially dropping the seeds, his bird picks up every fifth seed that he drops. So after he finishes planting his row of seeds, are there any seeds left? Yes, indeed there are, and infinitely many of them. Now for the second farmer. After every fifth seed that he drops, his bird picks up the first seed that remains in the row. After the second farmer has finished planting his row of seeds, are there any seeds left? No, each of the seeds gets picked up by his bird eventually. Isn't this strange? That both the farmers are working simultaneously and their birds pick up seeds at the same rate. But in one case, there are seeds left, whereas not in the other case. This situation arises because we are dealing with infinite sets, and two infinite sets may or may not be equivalent. So be careful with infinite sets.